So hi everyone. We are going to be talking about fantastic beasts and where to find them. That was the clickbait title. I'm just going to play the movie for the next 45 minutes. Kidding, I'm not. But that was the inspiration behind this talk. It's actually data science beasts and where to find them. All right, so a little bit about me. Hi, I'm Grishma Jena. I work as a data scientist with IBM in San Francisco. I work with the user research and design team where I'm one data scientist supporting about 80, 100 different user researchers, so it's an interesting journey. My background is in machine learning and natural language processing, which is one of the reasons I'm giving this talk, and I absolutely love being involved with the community, teaching, public speaking, so that's why I'm here. All right, so we're just going to pretend that this projector remote is my wand, right? It does magically move the slides. Perfect, you have a wand as well. Great, love that. And the rest of you have invisible wands. And let me start with a question. And I see some familiar faces from the workshop, so let's not spoil it for the others. How much data do you think was produced in 2022? Lot, yep. Yeah, I can't argue with that one. Any quantities, numbers you want to shout out? Very good. I'm impressed. You might be the first person to have answered this correctly. So it's actually 97 zettabytes, where one zettabyte is 1 trillion gigabytes. So they had to come up with a new unit called zetta just to be able to capture the amount of information in the digital universe. So it goes to say that the future of business really belongs to people who can make sense of these huge amounts and huge quantities of data. But before we go deeper into that, what percentage of the analytics insights do you think actually deliver some sort of a business outcome? So we know there's a lot of data, but how much of it is actually helping businesses in terms of getting insights? Is it 15 or is it 50? 15, 1, 5, okay. Less than 1%. You are very pessimistic. Yeah? 2%. Okay. Okay, you all are a pessimistic bunch. No one's going above 15, really? All right, it is 20%. A little better than 15, but yep, very close to 15. So out of all those zettabytes of data that is being collected, only 20% actually delivers some sort of an insight, which is shocking and frankly a little scary as well. This led Deloitte to publish a white paper recently that said drowning in data but starving for insights, which is essentially what's happening with the industry now. So why this talk? Well, anyone here has had every project they've ever worked on be an absolute success? Raise your hands. No smart overachievers in this room. We are all average. Cool. We all fail. Absolutely okay. The field of data science itself encourages a lot of experimentation and trial and error. So why don't we extend that into our lives, into our attitude as well? Especially because data science projects have, just like software projects, have multiple points of failures. And my hope with this talk is to destigmatize failure. It is not a personal flaw. It's just the nature of the work we do, and hopefully we can all talk about it and learn from our collective experiences. So the phoenix must burn to emerge, which is what we're going to go through. We're going to go through failures and try to become stronger. All right, bunch of trigger warnings. Some of the examples I'll be talking about does include COVID and the pandemic. So just wanted to put that out there. But so we go. I didn't say I was good at Photoshop, okay? No need to laugh, it's okay. All right, the first point of failure is data, which is kind of explanatory, right? Data science, data is the first point of failure. So let's see what things can go wrong. Sometimes I joke that we shouldn't be called data scientists, we should be called data scientists, because oftentimes I look at my data and I'm like, really? What were you thinking putting this in? Anyway, so the first thing is you could have low data maturity, because how many times have you had executives come in and say, we want to do AI? Okay, where's the data? We don't know. Is the data clean and complete? Kind of obvious. Is it standardized and relevant? And finally, is it free of biases? So let's see what that looks like. Data maturity. Oftentimes, executives want to come in and they want to say, we want to build some cool predictive models, we want machine learning, we want generative AI, right? That's the buzzword. But even before we can get to that stage, do we have data in a good format? Do we have enough data? Do we have well-represented data, clean data? I don't think so. Is the data clean and complete? So this reminds me of a case study where a particular data scientist was developing a machine learning model to predict credit loan application approvals, right? Whether a loan should be approved or whether it should be denied. And he built this machine learning model. It had great numbers, great accuracy, and he puts it into production. And it starts being a huge fail because higher delinquency rate, which means that a lot of the credit loans that were approved were actually defaulting. People were not able to, actually pay the money. Turns out that this model was trained on data from credit approval memos, which means that it was only trained on data that was existing for applications that had already been approved. So obviously, if you're going to run any application through that model, it's just going to say, yes, approve it, right? So that was an interesting case. Is the data standardized and relevant? There's a concept of Frankenstein data sets, which means that oftentimes we have multiple data sources coming in. And because those are coming from different data sources, it could be the same data point repeating across the sources. And if you don't do that filtering, that cleaning of the data well, your data point can come in the training as well as the testing. So when you actually test it on, test your model on the testing data set, it would actually perform better than it should because it's already seen that data in the training. It's almost like I leak the questions to the exam, and then I ask you to take the exam, and you're going to perform well because you already know what is going to be asked. So that's the concept of Frankenstein data sets. Biased data. So this happened during the pandemic, where a bunch of data scientists and medical professionals were trying to see if they could predict the cases of COVID, if they could have some sort of prediction, especially to do with the intensity of the ailment. And what started happening was they created this machine learning model, and the model incorrectly interpreted that the font of the hospital case files was an important feature because there were a lot of case files from particular hospitals that had really serious workloads. So it just assumed that, oh, if the font is bold and for this particular hospital, it means it's a severe case of COVID, just because there happened to be a lot more serious cases coming into that hospital. So yeah, that happened. This is a snapshot of a data set that I received at work. Looks fine, right? Nothing wrong. Except these were the column names. I'm not making this up. This actually happened with me. And this was my reaction. I had to mail the owner of the data and like, what is A, what is B, what is C? Till date, I have not received a good response. So yeah, if your data is in a bad condition, that is definitely the first failure or the first piece that you're going to encounter. All right, so the second beast that we may encounter is for infrastructure. How many times has this happened with you? Have your executives come in and said, we don't want to invest in infrastructure, and then wonder why data points don't make sense, metrics look a little off, dashboard is showing the wrong numbers? In that case, you might not have access to the data in the first place. Maybe your application, your data infrastructure is not robust. There are a lot of silos and gatekeeping, often happens in large enterprise companies. And of course, you could have vendor lock-in as well. So let's see what this looks like. Would it be possible to close the doors? Thank you. So access to the data is really important, right? Because if you don't have the correct infrastructure, it's going to be difficult. This happened a lot during the lockdown for the pandemic because we had different government bodies, different countries trying to assess what would be the economic impact if they had further stricter lockdowns. And they just had it all in different formats across different systems where no standardization was happening. So obviously that wasn't a successful effort. Well, I guess quiz question. What has 1048576 rows and 16384 columns? Perfect, who is that? Okay, you were correct. It is an Excel spreadsheet. Now, the problem with this is that the UK government was using Excel spreadsheets to store contact tracing and COVID data. And in October, I think a couple of years ago, they exceeded this limit, and people just kept saving data into that file and saving it. And they didn't realize that the data kept getting truncated because Excel's limit was met. And because of that, they missed out on reporting 16,000 cases that happened that month. So again, it's all coming down to failure of the infrastructure. A lot of silos and gatekeeping happens as well. I know I've been in the situation where I come up with an idea and I say, okay, why do silos exist? And I'm going to create something that's better and bigger and has all of these silos included. And then you just end up creating another silo of your own because there's somebody in the company that doesn't know about what you're doing. And then we're back to the starting point again, right? I've also had instances happen where I've gone to data owners and they have quizzed me, why do you need access to this data? What are you going to do with it? Why should I give you access? And in one particular case, I actually had somebody tell me, oh, that data is not, your use case will not be successful because the team doesn't have time to look at it. And I was like, okay, can I be the judge of that, please? All right, the next one is vendor lock-in. Also a true story. I sometimes say that third-party data storing vendors can actually be Hotel California. Once you check in, you can't check out. Also a true story. And you can never say goodbye. That's it. You are held hostage. Your data is held hostage. Okay, the third beast that we may encounter is with implementation. Prototyping and scaling with real data is really, really necessary. Cost-benefit analysis also is important. Make sure it's ethical. And finally, ensure that you're maintaining this. I had a case where we were working really hard, a team of me, a software engineer, a project manager, and we were expecting to get an application up and running that was expected to have about tens of thousands rows of data. And we kept trying to get access to it, but we kept encountering errors. So we got some partial access, we got maybe some subsets of the data, and we spent months building this, this application. And in the end, when we cleaned the data, filtered the data, took out what didn't make sense, we only had a couple hundred rows, which completely threw off all the metrics and all of the work that we had done. So a big lesson in there is to make sure you're prototyping and scaling with real data. Because you might think you have access to data, or you might think that there's a huge amount of data, but in reality, when you actually clean that data, when you try to understand it, analyze it, you might not be left with a lot. How many over here have heard of the Netflix $1 million challenge that happened some years ago now? All right. So Netflix came up with this idea where they wanted to crowdsource a solution for their recommendation engine. And they said, hey, we're going to send you all of the data sets. And if you can come up with a recommendation engine that beats our current implementation, we're going to give you $1 million, and then we'll use that solution. So a team came up, and they were able to improve the solution by 10%. So not a lot, but still an improvement nonetheless. Netflix gave them the $1 million, but never implemented the solution. Turns out that implementing that solution, rewriting the code, the architecture, all of it was actually way more costly than $1 million. And they just didn't feel that the cost benefit, it was just not the right ratio. So they ended up never choosing that solution. So make sure that you actually have a valid case and that it is cost efficient. Anyone here heard of Tay, the chatbot from Microsoft back in 2017, 2018? Yep, seeing a few hands. So Microsoft had this chatbot called Tay that was put up on Twitter as a Twitter bot. And you could tweet at it, you could tag it in posts, just the way you would with another Twitter user. And people were so nasty, and people were so racist and homophobic, and started tweeting all these terrible things at it, that it started learning from that, and in less than 24 hours, folks, that's humanity. Less than a day, the bot had to be taken down because it had turned extremely toxic. So that was a bad PR nightmare for Microsoft, but also a great example of ethics. Make sure that the data you're using is ethical and you have certain checks in place. Implementation, I think this is definitely a challenge that we're seeing, especially as a lot of information is quickly getting out of date and new information is always coming in. It's happening a lot with GDPR and data privacy laws, right? There are some new rules, some new regulations, new laws coming in, and you need to make sure that the data model that you implemented or deployed still has all of that current information in there. All right. The last beast that we're going to be seeing is culture, and it's definitely not the least. Oftentimes, a lot of executives, a lot of managers have the misconception that data science is very, very similar to software deployment, but that's actually not true, and we'll see why. You cannot use traditional agile methods, right? If you have a software project, if you have a development project, given 3 months, given the right requirements, given the right resources, you know at the end of 3 months you'll have something in hand, right? An almost working application. Unfortunately for data science, that's not the case. You could have 3 months, you could have the right data, the results could be inconclusive. You could have 3 months, you could not have the right data. You could have 3 months, not have the clean data, and all of those points of failures that we talked about could go wrong, right? Just the whole idea, the whole nature of data science is very indeterministic. It's experimental, it's exploratory. I would not be able to tell you how long creating a model that functions would take. It could take a week, it could take a year. It really depends on a lot of these factors. And because of so many variables involved that are dependent, interdependent, it's a change anything, change everything scenario, where you might tweak one parameter or one part of your workflow, or maybe start accepting data in a slightly different format, and that has a huge downstream effect, which completely changes the entire model and the pipeline. And what I mentioned earlier, inconclusive is a completely valid result. If you see that there's no conclusion or no evidence to support a particular hypothesis, that is still a success in data science. A few other challenges that you might have with culture, and this is an actual article that was published where a CEO says, if you want your company's AI project to succeed, do not hand it over to the data scientists. His reasoning was that data scientists can become so obsessed and involved with having really rigorous technical applications and using the fanciest algorithms. And I did see that happen with a lot of generative AI, deep learning. People want to use all the fancy tools, that they were actually failing to see if there was a business value attached to what they were doing or not. So hence, business value is really important. What is the use case? Why are you implementing it? Do you even need a data science solution, or is this something that can be, maybe automated in a different way, or can be done manually for much cheaper? Do you have multidisciplinary teams from different functions supporting it? What are the kind of tools? Is your team ready to invest in the right tools? And finally, do you have communication and alignment? Are you all having the right objective, the right alignment? Gartner did a review and said that only 44% of the data science teams add value. And I was hearing about this case where this data scientist was a part of a larger data science team, and the company wanted to become more data-driven. They hired, I think, about 5-10 data scientists, and within a year, every single data scientist was laid off. Because in that 1 year, the company could not see any business value that they were getting. Sure, they were working on things that they thought were cool, but it wasn't really giving any value to the business. So at the end of the day, that data science team became a cost center, and hence they were laid off. So that's a little scary. Do you have the right disciplines? Data science cannot exist in isolation. You need data engineers, you need machine learning engineers to deploy, you need maybe project managers, you need content curators to see if the data looks fine or not. So you really need to make sure that you have the right investment as well as the right tools to do all of this. And finally, communication and alignment. I think we heard a fantastic keynote earlier today, which talked about what you're saying versus what the other person is hearing. So that's no different for a data science project as well. So we saw the 4 Bs, or the 4 different ways data science projects can go wrong or can fail. We saw data, we saw infrastructure, we saw culture, and the last one was implementation. So these are the 4 things that it can go wrong. So yes, the past can hurt. Yes, nobody likes talking about failures. But to quote Lion King, the past can hurt, but the way I see it, you can either run from it or learn from it. So let's try to choose learning from it. All right, so how do we control these beasts? We know how data science projects can fail, but can we do anything proactively? Can we do anything to keep in mind that these failures don't happen, or at least reduce the risk of them happening? For data, make sure that your data is clean, it's standardized, it's relevant, and it is free of biases. We discussed a lot of case studies where these didn't happen, so make sure that that's not you. Remove duplicates, talking about the Frankenstein data sets. And leverage the concept of data contracts. This is something that's getting used more and more these days, where it's almost that you have a contract with the data owners or the engineers who are going to supply the data. It has a list of all of the fields that you expect, along with a good, accurate description. So just consider documentation of that entire, right? A lot of metadata, but also terms of what is the availability, what happens if the data gets erased, or if the data is not available, how frequently will it get updated. So ensuring that you have that data contract in place is actually really useful. When it comes to infrastructure, ensure that you have robust infrastructure and that your data vendors have APIs. You don't want to be locked in. Think about a centralized architecture. Yes, there are cons to this, but the pro of it is that you would have less silos coming in when you have that central data governing body. Documentation and data owners being involved is super important as well. And making sure that documentation is real-time, has real-time information of who the data owners are. I've had so many cases where I had to follow up with 5-10 people for one data source because the data owner listed in the documentation left the company years ago or moved into a different role, and nobody really knew who the data owner was. And finally, data governance in terms of who owns the data, who's responsible for maintaining it, how is the versioning done, how are you making it available. All of that also helps ensure a successful one. When it comes to implementation, make sure that your data as well as the application is ethical, right? Are there any ways it can be misused? Is there any part of the data that was maybe obtained without consent? We're seeing that happen a lot with ChatGPT, right? There's the whole lawsuit going against them where a lot of authors and artists did not consent to their works being used. So definitely not something we want to do. Cost-benefit analysis, similar to the Netflix thing, make sure that it's actually worth it to deploy and to use a machine learning model. Think about if this is going to be in prototype or in production. If it's prototype, it's an experimental project, you're doing it for fun, that's completely okay, or you're doing it as a proof of concept. But if you're doing it in production, start prototyping and iterating with real data so that you can scale it up. And after you do deploy it, ensure that you're monitoring as well, right? It could be accurate and correct today, but there are model drifts that happen, which just change the structure of the model and make it perform worse over time. As far as the culture is concerned, know that you have a strong business value. What are the objectives? Why is data science needed? Is there a non-data science solution to this? Is that a better option? Make sure that your stakeholders have realistic expectations. Tell them that this is not software development, this is not engineering. It has a different field, different requirements for it. And help them encourage experimentation as well as failure. That's when all the ideas will come in, when the data teams are allowed to take risks. Getting buy-in as well as sponsorship from leadership is also really important, especially since we're talking about infrastructure. That could be a huge investment in terms of time, in terms of energy, in terms of a lot of other dependencies on other teams. This is a data science template that I often use. So I usually start off with what is the business question that my stakeholders are trying to answer? Because that way I know that if this is actually related to a business value, or is this a cool, fun project that they came up with one day and now they want someone to work on it. What data do you have? Is there data that already exists, or do I have to do a hunt of data? Any existing or relevant work related to the project that they are talking about. Impact, often overlooked, but so crucial. Especially as a data scientist, it's really important for me to know what is the impact of my work. How will the value of this project be measured? So are there any metrics? Are there any benchmarks? Evaluation, what is the final artifact? Are you looking for a report? Are you looking for a dashboard? Are you looking for a model? Will this be a prototype? Will this be in production? What is the timeline that's expected? And then any additional context around the business problem, the analytical problem, and the engineering problem. So the different phases or different aspects to the data science project. All right, so we saw the 4 Bs, and we saw a few strategies to help encounter or protect ourselves against those beasts. But I do want to leave you with certain general tips or general advice. So what adventure is next? I've started doing a pre-mortem before a project actually takes place. So it's like a post-mortem, except it's done before. You ask your team to close your eyes and visualize that the project that you're about to embark on, really important project, 6 months down the line, is an absolute failure. And then you ask your team to list all the different reasons that could have happened. Did you not have access to the data? Did the executives not believe in your project and ask you to stop working on it? Did you not get the right tools? Did you not have the right discipline? What are all those points of failures? What are all the things that can go wrong? And once you list them down, try to proactively think of ways that you can reduce the risk, right? Is there something that you can be proactive about and that you can actively do? Or maybe there will be a few things that just aren't in your control, but at least having that knowledge is going to be very, very empowering. And research studies have done and said that, yes, right after doing a pre-mortem exercise, the morale of the team goes down. But overall, in the long run, it actually stays higher than without doing a pre-mortem. Try to do an assumptions and questions activity. So you list all of the assumptions that you have around the data, around your model, as well as any questions that you might have. And that, again, gives you some sort of a starting point, right? Are you making certain underlying assumptions? Even within your teams, do you have different assumptions from each other? So that helps with the communication and alignment aspect as well. Balance between permission and forgiveness. If you can quickly iterate on a small data project. That doesn't take a lot of time. That doesn't take a lot of money. Go ahead and do it and then ask for forgiveness. Otherwise, you will just be stuck waiting for permission, right? Change management, really, really important. And we're seeing this happen a lot with a lot more AI use cases coming into our lives. People don't trust AI the way they do trust other humans or maybe other non-intelligent systems. There was this particular case study where a data scientist was working in the banking industry. And this data scientist was trying to build an offer recommendation engine, right? So as a banking customer, you would have the availability to use certain offers. Maybe you get a high interest rate, or you get a free monthly, subscription, or something of that sort. And the data scientist went ahead and created a model. Again, looked great on paper, great metrics, great accuracy, and implemented it into their mobile app. So the users could now use their mobile app, which they were anyway using, except that they would see these banners pop up with the recommendations of offers based on what demographic they were, just a bunch of customer segmentation done. Nobody clicked on the offers, not a single person. This data scientist was very defeated. They then tried to talk to the users and understand that the users actually did not trust the app to give the right recommendations, which is why nobody clicked on those offers. The team then worked and changed things around, and instead of giving it directly to the customers or the users, these offers were now suggested to the banking relationship managers. Those were the people who the users had absolute trust in and good relationships with. So now the relationship manager, this bank employee, could actually see on their screen what offers were recommended for each potential bank customer or current user, and then they would then advise them, and that has a much, much higher success rate. So again, this has to do with change management. Make sure you're building trust and credibility. In this case, the trust didn't lie within the app, but the trust actually was there with the relationship manager from the bank. Doing a postmortem after a project, the opposite of premortem, and using the 5 whys exercise. Keep asking why 5 times. The project didn't go well. Why? We couldn't get the data in time. Why? We didn't know who the owner was. Why? It wasn't well documented. Why? Right? You keep asking and you try to get to the root of the problem. What exactly is causing that issue? So that's another exercise that I have found to be working well. With this, I ask you, what are the beasts that you have encountered in your lives, whether it be in the data science field or in the software projects field? Here's a list of resources for if you'd like to continue reading a little further or look into some of the case studies I mentioned and quickly. The first one is a nice white paper that actually talks about a lot of different attributes for things that can go wrong. So feel free to check that out. Finally, courage allows the successful woman to fail and learn powerful lessons so that in the end, she didn't fail at all, which means that failures are the stepping stones to success. Don't become the data scientist who lived, become the data scientist who thrived. Remember, those who cannot remember the past are doomed to repeat it, or as I like to say, are probably data science models with bad accuracy. Feel free to scan this QR code. It will take you to a feedback survey, and if you add your email to the feedback survey, I'm happy to send over the list of resources as well to you. But that's it from me. I'm happy to answer any questions, and thank you again so much. I hope you all feel a little more courageous to share your failures the way I did on the stage. And let's just all learn collectively from our experiences. Thank you.